All right, guys, welcome to this page of the notes. What we're going to do now is get our first look at the method of solving a system of equations known as elimination. And here's the way the method is going to work. What will happen is if you take a look at the system that you have been given and you notice that one of the variables in your system of equations has the exact same coefficient, opposite signs. For example, I have a positive 5y, and in my other equation I have a negative 5y. This system of equations is perfect for the method known as elimination. And what we're going to do is we're going to add the equations together. Those y's will drop out. All I'm left with is x. Take a look at how this works. I am going to add these equations together. So I will have 4x plus 5y equals 1. I'm going to add to that 3x minus a 5y is equal to 0. I want to add these equations together. Well, what happens when you add a positive 5y plus a negative 5y? Yeah, they cancel out, right? It's 0. So we go ahead, cancel those guys out. We've eliminated them, hence the name of the method, the elimination method. We're eliminating a variable. Add up the rest of it. 4x plus 3x gives me 7x. That's all equal to 1 plus 0, which would be 1, which means I have 7x is equal to 1. Divide both sides by 7, and x is equal to 1/7. Yeah, kind of a weird answer, I know, but it's fine. It is what it is. What you now need to do, well, is solve for y, right? I found the value of x, but I still need the value of y. And what you're going to do is pick one of the original equations that you were given. One of the original equations. Doesn't matter which one. As long as you do your arithmetic correctly, because we're just going to be substituting and solving for y. As long as you do that math right, both equations will give you the same answer. But I do like generally to work smarter, not harder. And since this equation is equal to 0, sometimes it's a little easier to do math with zeros. So that's the one I'm going to pick. We're going to do 3x minus 5y is equal to 0. I'm going to plug in what I know x to be equal to. So 3 times 1/7 minus 5y is equal to 0. Okay, great. Well, 3 times 1/7 would be 3/7. Minus of 5y is equal to 0. Let me slide this guy up so I got some space to work here. I will need to subtract the 3/7 to the other side. Where's my pen? There it is. 0 minus 3/7 is going to be a negative 3/7, which is why I picked 0. Makes the math a little bit easier to do, at least in this case it does. To get the y by itself, I got to divide both sides by a negative 5. Okay, let's take a little trip back to middle school when it comes to these mixed fractions. Hopefully what you'll remember from middle school, when you have a fraction in the numerator of a fraction, you have something like x over y, all divided by z. Well, all you have to do, right, is you could do the keep it, change it, flip it. It would work the exact same way, but there's a little shortcut that just simply says take that y, drop it down into the denominator, and x is equal to y times, it's equal to x over y times z. Well, that's exactly what I've got here. I just take that 7, drop it into the bottom. The negatives are going to cancel each other out, and I wind up with 3 over 35, or 3/35. So what I have now is a solution to my system of equations. My solution is the ordered pair x, which is 1/7, y, which is 3/35. A weird, yes, I know. It's a little awkward, but that's okay. It will happen, so please be okay with fractions. This is Algebra 2. Fractions are friends. You should be okay with doing this. And I know because I get a solution that is an ordered pair that my system is both consistent and independent. The lines are independent of each other. Now, what happened in this one is it worked out beautifully because what I had was a variable, the y, that had coefficients that were the same and opposite in sign. What happens if you don't have a variable with the same coefficient that is opposite in sign? Well, head on over to the next page of the notes and we'll take a look at a slightly more complicated version of the elimination method. So, head on over and I'll meet you there.